Boolean expressions can be minimized using another technique apart from Boolean algebra, and this other technique is called Karnaugh maps. However, in order to minimize a Boolean expression using Karnaugh maps, our Boolean expression has to be in this form, where we have a number of terms that are being ORed together, and each term contains all the inputs of that expression, in this case, x, y, and z. Now, Karnaugh map is a graphical technique of how we can minimize a Boolean expression. So the first thing that we have to do is we have to plot this expression in this Karnaugh map, which is a table-like structure. In this case, where we have three inputs, x, y, and z, we are going to plot x against y and z. Now, we have to write each combination of each input in this table, and we know that x can either be x0, which is represented by 0, or it can be a 1, which is basically x. Y and z can be either a 0, 0, or a 0, 1, or a 1, 1, or a 1, 0. Please note the order of how I have written these binary patterns. 0, 0, and 0, 1. Then, instead of writing 1, 0, as we usually do, I have written 1, 1, and then 1, 0. The reason is that in order to create a Karnaugh map, we have to make sure that from one column to the next, there is only one bit which is changing and one bit which is common. For example, in this case, the first bit remained common and the second bit changed. In this case, the first bit changed, but the second bit remained common. And in this case, the first bit remained common and the second bit was changed. Now, these represent y and z, so we can write here y0, z0, y0, z, y, z, and y, z0. Now that our Karnaugh map is formed, I can draw some lines. So this is our Karnaugh map, and now we can fill in this Karnaugh map accordingly. By filling in the Karnaugh map, we mean that we will fill each term of our original Boolean expression in its right cell. So for example, this one, x0, y0, z0, is this cell. So I'm going to write 1 there. This one, x, y0, z0, is this cell. We have x, y0, z0. The third one, x0, y0, z0, is this, x0, y0, sorry, it's x0, y0, z. So x0, y0, z is that one. And the third and the fourth one, x0, y, and z. x0 is this row, and y and z is this column. So it's that one. The other cells are going to be filled with 0. Now, the next step, once our Karnaugh map is completed, is to group the Karnaugh map. And by grouping, we will be able to minimize. Now, when we're grouping Karnaugh maps, we can group either in vertical fashion, like that, or in horizontal fashion, like that, or in a squarish or rectangular-like fashion, like that. We cannot use diagonals. And in this case, the grouping can be done on these ones, and it is very important that each group will contain a number of ones equivalent to the weights of binary. So, in other words, we can group groups of 1, 2, 4, and 8. In this case, we're going to have a group of 2 ones here. And when we do the group, we have to find what is common. Here we have y0 and z0 common in these 2 ones. So I'm going to write down that this group will give us y0 and z0. Then here we have 2 other ones which we can group in a horizontal fashion. And these will give us as common x0 and z. So now we can say that our minimized Boolean expression is f equals y0 z0 or x0 z. If we group all the ones in the least amount of groups, and each group will have the maximum possible ones, then we can say that our expression is fully minimized. I suggest you see the other videos of Karnaugh maps to understand this technique better by seeing other examples.